in the previous video we have already seen the circuit diagram how to write down for sum. So now we write the circuit diagram for carry. It is very easy. That is AB plus BC plus CA. So you require 3 AND gates, right? So let me write down A, B and C. Okay. So these are the 3 inputs. Okay. So A into B. First is what? A into B. So therefore I am taking 1 AND gate. Okay. Next is what? B into C. So you can take it here itself. So this is B into C. Next is what? C into A. Okay. C into A. So this is C and this is A. Okay. So this is what the expression. So this is what the circuit diagram for these 3 terms. So now I have to use OR gate. So as I have already told you, you can use a 3 input OR gate, but in the laboratory there is no availability of a 3 input OR gate. So therefore we will just stick on to the 2 input gates. So this will be added first, then finally this can be added. So this is your carry. Okay, this is your carry. So this is the circuit diagram for this particular expression. So now next important thing what you have to write down, you have to write down the pin numbers. So how many AND gates are required in order to construct this carry? 3 AND gates. And how many ICs are required? Only 1 IC is enough in order to show the carry. Okay. So 1, 2, 3, 4, 5, 6. 8 we are not using, sorry 7 we are not using, 8 is the output, 9 and 10. Okay. Next 1, 2, 3, 4, 5, 6. So this is how we are writing the circuit diagram and also the pin numbers for the respective gates, right? So copy down properly, then we can go for the next concept, that is half subtractor. Okay. So the next concept is what? Half subtractor. So what is meant by subtractor? Subtractor means it just, what is meant by adder? It was just adding the 2 bits. Subtractor, half subtractor means it just subtracts. I'll just tell you how it will get subtracted. So the block diagram of the half subtractor looks like this. So there will be 2 inputs. For full subtractor there will be 3 inputs. For the half subtractor there will be 2 inputs and the name for the inputs are A and B, and the output is, there we were writing sum and carry. Since we are subtracting, the result is called as difference. The result is called as difference, and instead of carry here you have to use the name called borrow. Okay, don't be confused. So the truth table looks like this: borrow and difference. So 0, 0, 0, 1, 1, 0 and 1, 1. Okay. So these are the binary representation. Since I am considering the 2 variable, the length of my truth table will be 4. So now how to get this difference and borrow? Very important, try to understand it properly. So now what I will do, 24 minus 17. I am just giving a simple example. This is a decimal number. So 24 minus 17, how you will subtract? So in your school days you have already learned the subtraction. How you will do? 4 minus 7, you will start from this end, right? 4 minus 7 is impossible, it is not possible, so therefore you will take the borrow. So whenever I am taking a borrow, this 2 will become 1. So whenever this is becoming 1, here I will be adding 10. So here you will be getting as 10 plus 4, that is 14. 14 minus 7, it is equals to 7, and 1 minus 1 is equals to 0. So 24 minus 17 is what? 24 minus 17 is what? It is 7. So this is just a simple example I have given with respect to the decimal number. So with respect to the binary number, so 0 minus 0 is what? It is 0 only. Okay. 1 minus 0 is what? It is 1 only. 1 minus 1 is what? It is 0. Now the important case is 0 minus 1. So can I go for 0 minus 1? No, it is not possible. You have to go for borrow. So whenever I am taking a borrow, so borrow will give you 2 units. So this 2. So 0 plus 2. You should not take it as 20 or that 2 plus 0. Because why you have to take it as 2? What is the base for the binary numbers? It is 2. What is the base for the decimal number? It was 10. So that's why in the previous example I have taken the whenever I am taking a borrow, you are adding 10. But the base for binary numbers is 2. So therefore I am adding 2. So whenever I am taking a borrow, so what it will become? This will become 2. 2 minus 1 is 1. So borrow I have taken. So therefore I have to update the borrow as 1. Keeping this concept in your mind. Okay. So 0 minus 0 is what? It is 0. Okay, it is 0. And are you taking any borrow here? No, you are not taking. So therefore borrow is also 0. So I'll just come back to this combination a little bit later. So 1 minus 0. 1 minus 0 is what? 1 minus 0 is 1. So the difference is 1. Are you taking any borrow here? You are not taking. So therefore borrow is 0 here. Okay. So 1 minus 1, the difference is 0. Are you taking any borrow here? You are not taking. So therefore it is 0. Come to this combination, that is 0 minus 1. It is not possible. You are taking borrow. Whenever I am taking a borrow, just update borrow as 1. Whenever you are taking borrow, just update the borrow as 1. Since you are taking the borrow as 1, so this will become what? 2. 2 minus 1 is 1. See? 2 minus 1 is 1. This is the difference. Understood? So this is how we are supposed to write the truth table for the half subtractor. Okay? Now again the same concept, whatever we have understood in the previous video, the same concept we are discussing now. I have to write the K-map for difference. I have to write the K-map for difference. So A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0 and 1. Okay, now I will write the cell numbers 0, 1, 2, 3, 4, 5, 6 and 7. Okay, these are the cell numbers. Now I will start copying these values in, here what is the mistake I have done? What is the mistake? I have to consider only the 2 variable. This is not a 3 variable, it is a 2 variable. 2 variable K-map. So 0, 1, 2, 3, A, B, 0, 1, 0, 1. Okay. So now I am writing the K-map for difference. So here comes a 0, 1, 1 and 0. Okay. So the grouping will be as usual for the half adder. So this is A into B bar and this is B into A bar. So what is your sum? What is your difference now? What is your difference? It is A into B bar plus A bar into, that is nothing but what? A XOR B. Okay, A XOR B. But we are not bothered about XOR operation because in the experiment itself they have asked you have to use only the basic case, that is AND, OR and NOT. So therefore we are not representing this. So this is the final expression for difference. Now I will write down the K-map for borrow. Okay, so here comes AB 0, 1, 0, 1, 0, 1, 2, 3. So now here is 0, 1, okay, 0 and 0. So this is the different expression. So this expression is common for both difference of half subtractor and sum of half adder. Okay, carry was what? What is the expression for carry in the half adder? It is AB. Now we are getting the expression for borrow. So here you will be getting only a single group, and what is the expression for that group? It is A bar into B. So this is your borrow. Okay, so this is your borrow. Okay, this is your borrow. I will be not writing this circuit for the difference. Why I will not write the circuit for the difference? Because this circuit is same as the sum circuit. This circuit is same as the sum circuit. Okay, sum circuit of half adder. So therefore I am not writing this one. I will be just writing the circuit diagram for this. So whenever you are, but in your observation, I repeat once again, in your observation you have to write the circuit diagram for difference. But I am not teaching the circuit diagram for difference because it is same as the sum in the half adder. Now what is the circuit diagram for this borrow? It is just an AND gate and one NOT gate, right? So this is your circuit diagram for borrow. Okay, so what is the inputs that you have to give? A, B. Here you will give it as borrow. Okay, so what is the pin numbers? It is simple 1, 2, here 1, 2, 3. So this is the pin numbers for borrow. Okay, keep all the circuits ready. So therefore we can easily implement the circuit in the lab.